Least common multiple (LCM) refers to the least number which can be divided by a given set of numbers without leaving a remainder. Now, to get LCM, this is the procedure to follow. Number one, we write each number as a product of its prime factors in power form. And I've reminded you that a prime factor is a number which can only be divided by 1 and itself. Then pick the prime factors which appear on the products, whether they appear on all the numbers or not. And where a prime factor appears on 2 or more product numbers, you pick the one with the highest power. Note that every factor, whether it appears on one or all the numbers, must be captured when calculating the LCM. We have two questions here to serve as an example. The first question wants us to get the LCM of 84 and 120. So starting with 84, we look for its prime factors. The prime factors of 84 are 2 times 2 times 3 times 7. If we write that in power form, you can see 2 appears twice, so we shall have 2 squared times 3 raised to power 1 because 3 appears once, and then times 7 raised to power 1 because 7 appears once. That's what we have here. Then for 120, the prime factors are 2 times 2 times 2 times 3 times 5. 2 appears 3 times, so we shall have 2 cubed. 3 appears once, we shall write it as 3 raised to power 1. 5 appears once, we shall write it as 5 raised to power 1. Now to get the LCM, we shall consider these ones that we have here. You can see there is 2 squared here and 2 cubed. Pick the one which has the highest power among these two, which is 2 cubed. We have it here. And then we have 3 raised to power 1, 3 raised to power 1. You can pick any because they are equal. I've picked 3 raised to power 1. Then, although a factor does not appear on both numbers, so long as it appears either in this first number or the second one, so long as a factor appears, it must be considered when finding the LCM. So you realize there is 5 here raised to power 1. We have to shortlist it, although it's not up here. Then 7 is also here, also, although it's not down here, we also have to include it. Here you need to note that even if a factor does not appear in the other number, it must be taken into account when finding the LCM. When finding the LCM, you consider both those factors which appear on both numbers, like these 2 and 3, and you also include those that appear in any of the numbers that you are looking for the LCM. So when you multiply this, you'll get 840. The second question wants us to get the LCM of 8, 72, and 120. So we have for 8 can be written as 2 times 2 times 2, that is 2 cubed. 72 can be written as 2 times 2 times 2 times 3 times 3. So this will give us 2 cubed because there are 3 of them, times 3 squared because there are 2 3's here. So that's why we have times 3 squared. 120 will give us 2 times 2 times 2 times 3 times 5. So this one in power form will be 2 cubed times 3 raised to power 1 because there is only 1 3 here, then times 5 raised to power 1 because there is only 1 5. So the LCM will be, we start with the 2, we have 2 here, cubed, cubed, and cubed, so you can pick any. Then we have 3 raised to power 2 and 3 raised to power 1. You pick the one with the highest power, that is 3 squared. And then 5, we have only 1 5, that's raised to power 1, so we also have to include it here. I repeat that when we are finding the LCM, every factor that has appeared in either any sum or in all those numbers that we want to find the LCM must be captured here. You can see 2 appeared on all of them. We picked the one which has the highest power. Coincidentally or by good luck, all of them have the same power, so we pick the one of them. 2 appears on 3 appears on 2 of them. We have 3 squared and 3 raised to power 1. We pick it still. Pick the one with the highest power, that is 3 squared. 5 appears only in 120 and it's raised to power 1. We also have to include it. When you multiply them, you will get 360.